All right, problem 1. We want to take the derivative of this function. Notice we actually will use the chain rule twice. Once there and once there. And keeping in mind that the derivative of sine of x equals cosine of x, and the derivative of the natural log of x equals 1 over x. So first, I take the natural log of the outside function. I mean the derivative of the natural log of some thing there. That'll be 1 over that thing, right? Times, now the natural log of, the derivative of the inside. Derivative of sine is cosine, so cosine 4 alpha times the derivative of 4 alpha, which is 4. So this is 4 cosine 4 alpha over sine 4 alpha. We used the chain rule twice, didn't we? We started at the outside and we moved to the inside. Alright, here we have a product rule. There's the F, right? There's the G, and we're going to have the chain rule there. So let's refresh. The product rule says if you have f of x times g of x, then the derivative is f prime g plus g prime f. So we'll start. The derivative of w to the third is 3w squared times g as it is, plus f as it is times the derivative of natural log of 6w. So it's times 1 over 6w times the derivative of the inside, which is 6. So 3w squared, natural log of 6w plus 6w cubed over 6w. So we have a little bit of simplification to do here, don't we? So it should be 3w squared, natural log of 6w. Right? Making sure I get the same answer, plus w squared. Alright? If you want, you can factor out a w squared, but I don't think you need to. So, product rule and chain rule. Alright. Implicit differentiation. Right? So anywhere we have to differentiate a y, we're going to be adding that dy dx. It says differentiate both sides and solve for dy dx. So let me put this here. Alright, start with this first term. Well, that's just the power rule, right? 18x to the 17th. Power rule here, 2y, but now dy dx. And the derivative of a constant is 0. So let's solve. I'm going to subtract this over. Right, so I have 18x equals negative 2y dy dx. Oh, sorry about that. Let's go back. What happened? There it is. Divide by negative 2y, right? dy dx equals 18 over negative 2y, sorry, x. And I can simplify that. That'll be negative 9x over y. Alright? Okay, just got a little bit out of order, but that's okay. Let's look at the next thing. Alright. Differentiate both sides of this again with respect to x. So anytime we have a y, we have to do the dy dx. Here we'll use the product rule, won't we? Alright, so the derivative of x is 1 times y plus x times the derivative of y. That will be 1 times dy dx, won't it? Plus the derivative of x is 1, the derivative of y is dy dx equals 0. I will subtract this over and I will subtract that over. So we have y plus 1 equals negative x dy dx minus dy dx. Let's pull out a dy dx, and we have negative x minus 1. Divide by negative x minus 1 on both sides, right? So dy dx should equal y plus 1 over negative x minus 1. I'm just going to back up and make sure we covered, oop, we did miss a few here, didn't we? So, I'm going to move to this one. On what intervals is this concave up? Well, first derivative gives us the slope. Second derivative gives us the concavity, right? So we got to take some derivatives. So if y equals natural log of this, we'll use the chain rule, right? Chain rule. First derivative is 1 over, right? Don't forget, derivative of natural log of x is 1 over whatever that x is. X squared plus 25 times the derivative of the inside, which just happens to be 2x. So I'm going to rewrite that as 2x over x squared plus 25. Well, now I'm going to use the quotient rule, right? Which says if we have an f on the top and a g on the bottom, it's f prime g minus g prime f over g squared. So the derivative of the top is 2 times the bottom minus the top times the derivative of the bottom, all over, oops, squared, that should be squared, all over the bottom squared. So we want to see if we can find some zeros. We can find where the inflection points are. Notice something. This denominator is always positive, isn't it? X squared plus 25 squared is always positive. So I believe we need to look at the denominator here and see, the numerator, and set that equal to 0. Let's see, 2x squared plus 50 minus 4x squared, right? So what do we get? We get minus 2x squared plus 50 equals 0. I'm going to say 50 equals 2x squared equals 25, x equals positive or negative 5, right, if I take the square root. So let's make ourselves a number line. We have 5 and we have negative 5. So what happens to this derivative at 0? Is it positive or negative? We have, sorry, we're running out of space. At 0, this is 2 times 25, and those are 0 over 25 squared. Well, that's positive, isn't it? Let's see what happens at 6. 2 times 36 plus 25 minus 4 times 36. Sorry, it's a little bit messy. 36 plus 25 squared. So if we check that, I believe this is going to be negative. So these would be negative, right? And because these x's here are squared, whoops, dagnabbit. Because these x's are squared, we should be getting negatives down at this end. So I believe it should be from negative 5 to 5. I will confirm that one. Let's go on. Sorry. Just want to make sure we get the same answer here. Oh, notice what I missed here. I missed carrying this along, didn't I? So there's the 17. So really, if I rewrite this answer, dy dx equals 18x to the 17th over negative 2y, which I can simplify to 9x to the 17th over negative y. Don't forget to carry that 17 along. Right, this one, I want to make sure I get to the same answer on my sheet. That's it, y plus 1 over negative 1, negative x minus 1. Alright, solve for dy dx, implicit differentiation. Alright, also chain rule, right? Derivative of natural log of x is 1 over x, plus the derivative of the natural log of this is 1 over this, times the derivative of this, which is 3y squared. The derivative of 3 is 0. Whoops, I forgot the dy dx, didn't I? All right, we're going to get this. It takes us all day. So I'll put this together. 3y squared. I'm basically taking this to the other side. 3y squared over y to the third dy dx equals negative 1 over x. These, I end up with 3 over y. I'm coming up here. 3 over y dy dx equals negative 1 over x. I'm going to multiply by the reciprocal on both sides. All right? So dy dx should be negative y over 3x. All right, so take a look at that. Stop it and do it in your head and see if you can get it. All right, here we have the sine of xy equals 6x plus 6. All right, implicit differentiation, right? So we also have the chain rule here, don't we? And the product rule. So the derivative of sine is cosine xy times the derivative of the inside. So we're going to do derivative of xy, which is 1 times y plus x times the derivative of y, and that equals 6. So these, notice that these are products, factors, right? So I could divide by this on both sides. See what I have there? Ugh, 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 ugh. All right. So now it looks like 1y plus x dy dx equals 6 over cosine xy. I'm going to subtract y. So subtract y from that whole thing, right? And now I have x dy dx equals this. Well, divide by x. This one's a little crazier, isn't it? 6 over cosine xy minus y all over x. All right, we did that one. Find the slope of the tangent to the curve at the point specified. So slope is our first derivative, so we'll take the derivative 2x plus 2y dy dx equals 0. I'll subtract 2x over 2y dy dx equals negative 2x. Let's divide by 2y dy dx equals negative x over y, right? Well, at the point 0, negative 8, if this is our slope, equals 0 over negative 8, which equals 0. What is the slope? The slope is 0. What kind of line is that? It's going to be horizontal, isn't it? All right, this should be a circle. If we graphed it, you don't have to, but this is a circle. It's centered at 0, and it's 0, 0, negative 8. Here we go. Tangent line is horizontal. Okay? Now we'll find the slope. Same thing. All right, so I'm starting here. 3x squared plus product rule. Derivative of 2x is 2 times y plus 2x times the derivative of y plus 2y derivative of y equals 0. I keep hitting this and it keeps moving back and it's starting to make me mad. Gotta get there. All right. So let's subtract this over and this over, right? 3x squared plus 2y equals negative 2x dy dx minus 2y dy dx. Factor out the dy dx. Negative 2x minus 2y. And then divide by negative 2x minus 2y. All right, at the point 1, 5, because this is what we have, right? The point 1, 5, 3 times 1 plus 2 times 5 over negative 2 times 1 minus 2 times 5. Let's see if we did this right. So that's 13 over negative 12.